The graph of the parent quadratic function and a transformation of the parent function are given. List the transformations that occurred and then write the equation of the transformed function in vertex form. Well, remember that the parent function has its vertex at 0, 0. So the first thing that we can take a look at here to kind of help us is what's the new vertex? And I'm going to mark that here. This is the new vertex. If we look carefully at our graph here, it looks like we have a turning point, which is also known as a vertex, at -2, -4. Well, once we realize that our turning point is -2, -4, that means that we went left 2 and we went down 4. And then we look at a couple other points here on our graph. And again, I'm going to fill them in a little bit more just to highlight them. But remember what the pattern of the graph is. From the parent function, we went 1 space to the right and 1 up. We went 2 spaces to the right and 4 up. In this particular picture, we still went 1 space to the right and 1 up. We went 1, 2 spaces to the right and 1, 2, 3, 4 up. Those are the only transformations that we have in this. And then we're going to put this in vertex form, and it's going to be y equals, don't forget your squared when you're writing this. There's not going to be any number in front of the parentheses, but left 2. That means we're going to write x plus 2, because remember we would change the sign to get the -2 in our turning point, and then we keep the sign down 4, -4. Part B, same kind of picture here, and we want to identify the transformations. And the first thing that I personally notice is that our graph is flipped over. And when it's flipped over, we say that we reflect over the x-axis. But again, let's look at our turning point, also known as our vertex, on this particular problem. And what we see is that our turning point is here, where I just put the point, and it looks like we went left, we have -4 and +5, which ultimately means that we went left 4 and we went up 5. We want to look at the pattern on the graph to make sure that we don't have any vertical stretch or vertical compression. We went 1 space to the right and 1 down. 1 space to the right and 1 down. We went 2 spaces to the right and 1, 2, 3, 4 down. And the going down here from the original graph of going 1 space to the right and 1 up is we didn't change the vertical distance any. The going down is from the reflection. So now that we've determined those are all our transformations, again, don't forget your squared, and it's going to be x plus 4. Again, we changed the sign to get the -4, so I had to change it to put it back in here. Keep the sign. And then what causes us to reflect over the x-axis? It is going to be a negative out in front of the function. Part C. Same kind of thing. And the same immediate response. Our parent function is here. I'm going to try to put it in red, and I'm going to have to erase it, probably, but that's the parent function. Where our vertex is at 0, 0. And now that you can see it on there, I'm going to erase that, just because I think it just complicates things. But now that you know which one's which, first thing that I noticed, just like that last problem, was that we're reflected over the x-axis. As we look at the turning point, which is also known as the vertex, it looks like our turning point is 0, 9, which means that we didn't move right or left at all. We only went up 9. The question is, though, do we have anything else in here? And again, note the cat from the parent function. It's supposed to be at 0, 0 there. 0, 0. Then we went 1 space to the right end, 1 up. We went 2 spaces to the right end, 4 up. But in our picture now, here's our vertex. We went 1 space to the right end, 2 down instead of 1 down. And because that distance of 2 is different from the distance of 1, we also, and I'm going to have to write it above here because I don't have enough space, but we're also going to have a vertical stretch. And don't forget to write the word vertical. I know that's the only kind of stretch or compression that we're dealing with, but at some point you're going to have to distinguish vertical stretch, or vertical compression, horizontal stretch, or horizontal compression. I know that we're only doing vertical in Algebra 2, but if you take college algebra or pre-calculus, you're going to have to know the difference there. So get in the habit of writing the vertical stretch. But I'm starting the problem like I have always. And it's y equals, and I'm going to write x minus 0. You could write x plus 0. 0 doesn't have a sign. So, but we change the sign and we keep the sign. The reflection, we saw the reflection a moment ago. We put a negative in front of the function. And our vertical stretch here is going to be by a factor of 2. Remember, in the original function, we went 1 space to the right and 1 up. But in the new function, we went 1 space to the right and 2 down. So that took us 1 times 2. The down part was the reflection. So this is, you could leave it like this, negative 2 times x minus 0 squared plus 9. Or y equals negative 2x squared plus 9.